I'm going to demonstrate another way of driving a die line. This is the sketch that I had. This is for the corrugated shipping box. So the reason the corrugation is being used is because it's being shipped. So we need that strength to withstand the shipping process. It's not necessarily using the corrugation to protect something fragile. I mean, that is also very good, but this one is less about that. It's about having enough integrity in this small little folding carton that it doesn't break during the mailing process. So this was for the folding carton tutorials that I'm creating, and it is for this dietary supplement. And it's this gray folder I have constructed over here. There are 4 of them. And all I did was build the geometry, the top panel, the back panel, and then the binder area. I didn't build the tablets or the vac form or all the other internal components because I just want to talk about just creating that die line to prove out the geometry. Instead of building a full 3D file of the assembled box, this will be backing into it by just creating the panels, the flat panels, by using the math and the dimensions to create the die line. And then once that's created, I print it out. I can put it on the cardboard and fold it up and see how it works. And then when it's time to do the 3D rendering, I can go back into this 3D file and assemble all the panels from the die line. So it's just another kind of workflow. The first time for the folding carton, I built a 3D file of the geometry and then took that apart to create the die line. So this is just a different kind of workflow. Some people it'll work well, and some projects it might work better for than others. So this is the sketch I have. It's actually quite interesting because it's very symmetrical. We have 2 little booklets, 2 little of the tablet folders on one side and another 2 on the other side. So it's just a mirror of the geometry. And it's also, you can mirror the top geometry to the bottom geometry. So it's very symmetrical in all directions. So it's quite easy to construct. So it's all about let's go back to this. It's all about the math and getting this to work. So what I mean by that is I have this little folder assembled as one part. And according to my sketch, I have them right on top of one. So once I build that, all I have to do is move a copy of that and space them out, which will be a little bit of an estimate because I'm going to put some cardboard in between. There's some of the corrugated. So it might be about like this. Be a little bit of guesswork and development. So once I have that, I'm going to draw the back panel. And I'm going to do this by unghosting just to save a little time here. But it's pretty straightforward. Let me find can't see them, so I'm going to guess. There it is. So what this panel represents is, I'll go back to my top view. It's the outline around the 2 books. Now you see I have a little bit of space. I don't do line to line because I know I'm folding up. I'm going to make this out of E-flute. E-flute is pretty thin. So you need a little bit of space. So when it folds up, the books aren't jammed in there and they have enough space so they can be slid out easily. That's a little bit of guesswork, but that's part of this process. By making an estimation on this die line, I can print it out, try it, and if it doesn't work, I can come back to this die line and make my modifications. Make it a little bit wider, make it a little deeper, and make adjustments and get it perfect. And then you try another one. It's a pretty quick process, but the back and forth iterative process gets you good results. So that represents the back. If you look at my little sketch, that's the back panel of one side. So now we need the edges. So again, I'll measure my little book, the binder area, and I'll add some space. It's an estimate. Add a little bit of space, not too much, but enough to do that. I've built this a couple of times, so I know this one's going to work, but I went through that iterative process that I'm showing you. So let's just unghost. So with that math in mind, you start to build these panels. So there's the top panel. And now I know I'm going to fold that material around to the front halfway down. So this line represents half of this panel, right to that line, because that's how much. And then, of course, I might be careful with my tolerances. I might decrease that material a little bit to make sure that it has enough room and stays square. Again, I guess. And then I start to build the rest of this geometry that I have. And I have my curve, And I have that. And I stepped that. There's quite a bit of a step down here because that got in the way. I had that and it jammed into the back of the box. So I moved that over quite a bit. So once I have all that built, these curves make a complete circle in the middle. That's just an aesthetic decision. The graphics this curve cut could have been lots of different things. And I thought about that, but I wanted to do this nice, beautiful round circle in the middle. So the same thing happens with the side. So we're talking about creating this little thickness here. In my sketch is that thickness on the side. So this is all pretty straightforward. It's just using the dimensions coming off of these two books and how much material do I need. This is the one detail that holds everything together. There's no glue on this structure. By folding up this side and folding the two top and bottom sides into position, the tabs snap into this little groove, create the divider I need in the middle, and there's no glue, and it's a hand setup. So it works really smoothly. This whole structure I'm building is based on a folder type of design approach. I didn't invent all this. I'm just modifying that something exists, which is perfectly fine in this process. So what we do here for this particular one, since it's so symmetrical in all directions, I can just mirror things around. This is pretty straightforward. So I have all that geometry on the top. I'm going to select that. So all I have to do is mirror that down. Since I have my snap on center, I have all my snaps are down here, and I have snap on center selected. So I'm just going to go right here, snap that down. Now I have all of that ready to go. It's going to ghost my books, my little folders. Let's see if I have unghost. This is the little binder area. There should be a line in here. There it is. So that represents both of these halves put together. If you look at my sketch, I'm folding it in half like a book. So this line here, again, it's a little calculation. It's double this line. And then since I'm folding over, I add a little bit of space to get that to work. So that represents that back panel. So all I have to do is just take all of this. And since it's symmetrical left and right and top to bottom, I just mirror that over. And that is essentially my entire die line. So just by thinking this through, obviously the sketch came first, having a plan, and then being able to execute this plan. So that's the die line. So this is ready to be tested. And I did this twice. I tested out 2 die lines, and I made some subtle modifications on the second one. And I'll bring those into class so we can see how that works. So again, for die lines, we want to print this out. I have this border. I just created a border that was a nice equal number. I'm going to tile this, so I print this out on several pieces of 8.5 by 11, and I tape it together to get it to work. Obviously, you can go over to the print room and have it done in one shot. It's a little easier. So I measured this at 20, let's see, by 22, and I know I can make those pieces work for 8.5 by 11. So if that's the size of my border, to get this printed out accurately, go into the image options, and I have this already set up. I have the 20 wide by 22 high, and I set the page up. I'm going to ghost my little image of the sketch, and it's going to fit. I don't want all that color, so I'm just going to go to line, wireframe. So that's my die line and ready to be tried. So again, non-glued, fold over, it works really well. I'm using my locking tabs to create the divider, so they have a double purpose. So it's a pretty clean structure, and then it folds in half and it works really well, and it accommodates a FedEx and USPS label. So then I would just save this out as a picture and test it. So that's just another way of deriving a die line in the 3D program.